Hey YouTube, welcome to DevOps Directive. This is the video that I wish I had watched when I was first getting into developing software for the web. It's designed in a workshop style, and I explain every command and click along the way so that you can follow along and recreate the steps on your system. I start from scratch, literally opening a blank text file representing the simplest possible web page, and then go through each step in the process from developing that and running it locally on your system through containerizing it into a production-ready server and deploying that server onto Google Cloud Platform. This is a long video, it's just under an hour, but I wanted to make sure that I had enough time to go into each step in depth and explain the thinking behind each configuration choice. I also, because I made the starting point as basic as possible, if you have some experience with web servers, you may want to actually look at the timestamps in the description and pick an appropriate point to enter along the way. Or if you're already comfortable with everything involved, you could just go ahead and go to the GitHub repository where I have a script that deploys this whole setup in less than 5 minutes so that you can have your next website deployed in no time at all. If you learned something from this video, hit the like button and consider subscribing. I've got a ton of educational content in the pipeline that I'll be working on over the next few weeks. Without further ado, let's get into it. I'm actually starting with just a completely blank working directory here, and I'm going to create a new file and name it index.html. That's just the convention for what a website file would be named. And then I'll just do, I'm not even going to make it valid HTML. Hello from DevOps Directive. Save that. So I could actually just load that file from within Google Chrome if I wanted. If I go here, open file, index.html, I can see that text. I'm going to make it a h1 tag so it's a little bigger. Save that. So if I refresh, it's much bigger text because I use that header tag. That's the simplest website you can have. It's just a text file with something in it, and then you can load it within Google Chrome. The problem with this is that it's loading from within this file path, users, my username, YouTube, etc., and you wouldn't want to expose that to the internet. So instead, we use what's called a web server that takes whatever files you put in a specific directory and serves those over HTTPS or HTTP, depending on how you have it configured, such that people on the internet can actually access that content. And so the simplest version of a web server that I have seen is just a one-line command within Python. In Python 3, it's going to be, let me make sure I'm in the right directory. Yep. And here's my file, index.html file. I can just do Python, and the default is Python 2 on Mac OS, so I'm just going to do Python 3 -m http.server, and then I'm going to tell it to serve on port 8000. So here we go, serving on 000, port 8000. So if I go to 0.0.0.0 :8000, I get the same result. Let's just prove that it is true. Python server, save. And then I refresh. Great. So now I'm taking that same file and I'm serving it using a very basic Python web server. This is a great utility to test things out, but it's not actually ready to be deployed to the internet. There's a lot of security features which are not embedded in this very basic server that you would get from a more production-ready, production-grade server, something like Nginx or Apache, or I'm actually going to use a product called Caddy, Caddy server, which actually does some nice things around configuring HTTPS in a very easy manner. Okay. What else did I want to do? Oh, the other interesting thing here is that this is being served from my MacBook on port 8000. There's no external traffic from the internet that can make it to my MacBook because of how my router, my Wi-Fi router at home is configured. But I could take another device on the same network. So in this case, why don't I do that? I'll do ifconfig. I'm going to get my internal IP address to see what IP within my internal network this computer is actually using. I'm going to grep for 192 is what it should start with. Okay, so if I get this IP address 192.168.0.101, I should be able to go onto my cell phone or any other device that's connected to the same Wi-Fi network and load it up. And here we go. I was actually able to load that site on my cell phone. Sorry for the glare there. Because it's being served on port 8000 at this IP address. There'd be no way to access this from the external internet. I could set up a port forwarding rule that would allow traffic coming in to the IP address assigned to me by my internet service provider to this computer to actually be able to access this. But I don't currently have a static IP that I'm paying for, so there'd be no way to actually configure it such that this would be a stable deployment. Because of that, I'm going to use a web host. In this case, I'm actually going to deploy it to Google Cloud Platform. But before I do that, I'm going to move it into a more secure web server. So like I said, I want to use Caddy. We can go to their download page, and we could use this to install it. You can also just do brew install Caddy if you use Homebrew. I've already done that, so I'm not going to install it again. But then to use Caddy, we just make sure that we're in the right directory. Again, I'm here, and I can just run the command Caddy. The default is for it to serve locally on port 2015. I'm not sure why they chose that port. Maybe it was the year in which Caddy was created. But if I try to go to 8000 like I did before, there's nothing there because that Python server is shut down. However, if I go to port 2015, I get the website again. And so here I'll change it. Caddy server, save, reload, and there we go. We've got the website being served from within Caddy. Okay. Now, port 2015 is fine for use locally, but when we actually run this in a virtual machine on Google Cloud Platform, we're going to configure the firewalls such that traffic can only reach that machine on two ports, port 80 and port 443, where 80 would be HTTP traffic and 443 would be HTTPS traffic. And so I want to actually change this such that it's not serving on 2015, it's serving on 80. And the way that we configure Caddy is by passing it a what's called a Caddyfile. So if we go here, new file, Caddyfile, capital C. And the formatting for this is I'm going to do localhost 80. And that's how I'm specifying the domain and the port. And then we pass it any directives within this block here. I don't think it actually matters much. I'm going to do log to standard out and errors to standard error. This would mean that logs should go to the console and errors should go to standard error, which will also be the console here locally. Don't need that. So if I kill this server and then rerun it, we see instead of serving on port 2015, we're actually serving here on port 80. So if I load this, it's gone. If I go to port 80, sorry about that. HTTP / localhost 80. There we go. Again, let's prove to ourselves on port 80. There we go. Okay, so it took that Caddy file as the configuration, and it is now serving on port 80. That's pretty good. At this point, we've gone as far as we need to locally. So that's kind of the most simple setup, from hello world index.html to running that from within a production grade web server. There are some additional configurations we'll want to do once we get it live on the cloud, running on the internet, such that we can configure HTTPS. That's a little tricky to get running locally, so I'm just going to skip it for now. But we can move on to sort of the next part in the setup of manually setting things up on Google Cloud Platform. So I'm just going to go to Google Cloud Console. So this is the GUI interface for Google Cloud. I already have a project created here, but if you didn't have one, you would need to create a project yourself. We're going to go to Compute Engine and VM Instances. So Compute Engine is Google Cloud Platform's product for deploying virtual machines. You can choose from all sorts of different image types, and those image types are going to be your operating system. So in this case, I'm going to create a new one. This one running here is actually the F1 micro instance, so that's their smallest instance type, and you can get one per user and run it for free within their free tier pricing model. So I can actually run my DevOps Directive website, which I'm using almost an identical configuration to what we're going to end up with at the end here. And I run that on this free tier virtual machine and don't have to pay for anything. I have to pay just for a static IP address, which ends up being like less than $1 a month. But it's been a really good setup so far. So this is kind of me walking through the process of what I did to get to the final install or configuration that I'm using for that website. So I'm going to create a new instance here. Create instance. We'll just leave it named instance 1. I'm going to choose that F1 micro as the cheapest one. So if you have more than one, you have to pay for it. And I think it ends up being about $4.28 a month for this machine type, but we're only going to leave it running for 15 minutes, so it should be pennies. We are going to use the Debian is the default. That's a Linux variant that should work just fine. We're not going to configure anything here. We do want to allow HTTP traffic. So if we didn't click this button, then when we tried to access the server, that web request wouldn't make it in. Actually, why don't we do that as an experiment? We'll leave it turned off for now. We'll try to access it. We'll see that it fails, and then we'll go configure this to be on, and that will allow us to actually access things. So if I click create here, it's going to provision that instance in Iowa, since I chose US Central 1 as the region. And it just takes maybe 30 seconds, or not even, came up already. And so here we are, we've got our instance, and I'm going to click this button to SSH into it. So this just gives me a secure connection where I can have a shell running on that virtual machine to do whatever I want. We're manually setting up the server this time, and the reason for that is it's the simplest way to get going. We will eventually, like I said, step back, containerize our web server and site such that we can deploy it without any of this manual configuration on the virtual machine itself. Okay, so we have a shell here running on that machine. I'll move it up so I don't get blocked by myself. And so we want to do, first we want to install Caddy. So from the Caddy website, there was this nice one-liner. I believe we can just run that. Okay, so we now have Caddy installed on this machine. Let's create we'll create that index.html. We'll do touch index.html. Let's copy it over. And so here, using Caddy server on port 80 on GCP. Sorry for the colors there. Hopefully that was legible. So now we can do this. So there's our new index.html, and we're going to run Caddy here. We also need that same Caddyfile because we want it to be port 80. So I'm going to do the same thing. I'm going to copy this Caddyfile in. I could also run a gcloud command to move these files directly rather than doing what I'm doing of creating the file and pasting in the text. Either of those options is fine. We now have our configuration file there. And so if I just run Caddy, okay, so we got, it tried to bind to port 80. It's trying to serve that website on port 80. Many systems have 80 and 443 reserved, and so you have to actually run this in a privileged fashion. So if I run sudo caddy, it will then succeed and will be serving that index.html on port 80. But like I said, we hadn't enabled that firewall. So if I try to go here and then load that IP address, so that's the external IP address, if you missed that, for this virtual machine. This is the address we would use to connect to, and eventually we'll use to point our domain name to, such that when you type in your domain into your browser, the DNS will resolve to this IP address in the back end and actually send that request to this IP address. But when we try to load it here, nothing happens, and that's because we don't have that firewall rule configured. So we're actually going to go edit this machine. I'm going to go here, edit, allow HTTP traffic, save. So it's going to add that firewall rule that will allow web traffic to actually make it to this instance and then make it into the server. It should only take a minute here. Looks like we are good. And so now, so now the issue is that I have specified this as localhost, so it's only accepting requests over localhost. So I actually need to modify that in this case to accept requests over other from other domains. So I could do a few things. I can leave it blank, and it should accept requests from any domain. So now, if I run caddy, sudo caddy, and reload, I get the website. Cool. So that's great. We have our web server running on a Google Compute Engine instance. It's serving on port 80, and it's accepting requests from any domain. So at this point, we have made it to here, and that's great. However, it was not ideal that we had to provision the instance, then manually go into the instance, install the web server, move the files onto the server, configure things. It just makes it such that if we wanted to, for example, scale this instance up and use a much larger virtual machine to handle more traffic, for example, we would need to do those manual steps each time, or maybe write a script that would handle that for us. Ideally, we could just provision this server and treat it as immutable, such that once we provision it, nothing about it will change, and we can contain our entire application, in this case the web server and site, into a bundle that we can plop onto that virtual machine and have no issues running, regardless of whether we're running on Google Cloud Platform or AWS, etc. And so the technology that came along not too long ago that actually allows us to do that in a relatively easy fashion is called Docker and containers. And so containers take all of the the necessary dependencies and bundle it up into this container image, which is then able to be run on a wide variety of platforms in a relatively lightweight manner. So we'll actually be able to bundle that up, deploy our container to GCP, not have to do any manual configuration on the virtual machine itself, which will make it much simpler to maintain down the road. So there's a little bit of upfront cost in sort of getting things configured, and one additional layer of abstraction where we're wrapping our web server in this sort of virtual. It's not quite a virtual machine, but it's a virtual. I guess container is the right word for it, where it'll have all its dependencies bundled up into one object that we can place and deploy to a variety of different locations. So I'm going to kill this connection to our web server, and I'm actually going to kill this machine as well, because we're going to create a different machine, a virtual machine running container optimized OS, which is Google's operating system that they've developed that works really well with containers and provides some nice security features out of the box in terms of what about the host system is accessible from the containers themselves. So I'm going to delete. This should terminate. Kill that. Okay. So, like I said, we're moving back to our local system here. We're inside of our working directory. We've got our index.html and our Caddyfile, and we want to use Docker. So I have Docker installed already, but I believe there's a brew cask install Docker if you wanted to install that on Mac OS. You can just Google how to install it if you're working on Windows or Linux. The nice thing about Docker is that once you are using it, so maybe the installation process might be different, but once you are actually running Docker commands, those should be transferable across almost any platform that Docker runs on. So it sort of allows people working on different architectures and different OSs to more easily collaborate and work together on development projects, and ensures that when you develop something locally, it's going to operate the same way in production as it does on your development system. Okay, so for Docker to work, we want to use a Docker image. I'm actually going to walk all the way back to that simple Python server, and we're going to take that and we're going to wrap it in a Docker image. So to start, I'm going to do Docker run -it. That'll give me an interactive terminal that I can actually work with. If you just did Docker run Python, it would terminate immediately, and then I would not be able to interact with that session. So it's going to be, just pick an image, 3.8 -alpine. Alpine is another Linux distribution that's very popular for building containers because it's relatively lightweight in terms of its size. So that gave me an interactive shell. I actually want to do this. So that D command runs it as a daemon, such that I can, it returns and I can then connect to this after the fact. So now we have, if we do Docker PS, it'll list all of the currently running containers. This one is based on that Python 3.8 image, and we can see that it was created 12 seconds ago. I actually want a shell within that, and so I can do Docker exec it, then the container ID, and then bash. It doesn't like bash, it doesn't have bash installed. If I just do sh, there. So we have a shell now running inside of that container on our system. And I can do Python. Okay, so there I'd have a Python interactive session. Like the web server, we now have this isolated environment on our system that doesn't have access by default to the file system of the host machine. So I'm in this directory and I don't have that index.html or that Caddyfile accessible to me. For now, I'm going to do the same thing that I did on the virtual machine in GCP and actually just create these manually. Later, I'll show you how to mount in the file system such that we can access them directly. So I'll just do touch index HTML. Oh. Again, we're going to copy this. Do that. And so now we are using Python inside container. Okay, and so now we want to actually run that same Python server command. And so we're serving on port 8000 localhost. And so this is going to fail almost for the same reason that we first failed on the cloud deployment, and that's because Docker is isolated and by default doesn't have access to serve on port 8000. So it's serving from localhost within that container, but our host machine has no way of actually accessing port 8000 unless we grant it that access. So I'm going to kill this. I'll do exit. And so then when we actually, I'm going to stop this container, Docker stop, there we go. When I launch that container, I need to tell it to port forward port 8000 from my host machine, my MacBook, to that container image. So I can do that by passing it a -p flag and say 8000:8000. That's going to pass any request on port 8000 to my MacBook into that container on port 8000. So again, we're going to exec into it. This is where you'll see one interesting artifact of it being inside that container is that when I stopped the container, it destroyed all of the files that existed there. So I'm actually going to have to create these again. Index.html. So this is using Python inside container take 2. Cool. Great. And so then I'm going to rerun our Python server command. And you'll notice this time I didn't have to specify Python 3. That's because this is a Python 3 container image. So the default Python version within that is actually 3.8. Rather than when I was running locally on my MacBook, the default version was 2.7, I believe. So it needed to specify I need to specify Python 3 when I ran that command. Now we're serving on 8000. And so if I access it, I can actually see the website being served, the web page being served with that new index.html file. Okay, so we see that we can build, or we can run this container image. We can serve that web page on port 8000. We use that port forwarding command to actually shuffle traffic between my my MacBook localhost and the localhost within that container. And so now let's move on to actually do the same thing like we did before. We're building this progression. So we did our simple Python web server inside a container. Let's move to using the Caddy Webserver also inside a container to serve the same web page. Okay. And so let's see, DockerHub, Caddy server. So DockerHub is a website where lots of container images, publicly available container images, are hosted. This container image with over 10 million pulls, that means 10 million times people have downloaded this to use it on whatever application they're running, is the most popular one for Caddy. It is the one that I am using. we will do something similar. We see this is actually the name of the container image. Abiosoft, I believe, is the developer's name who created this container, this Docker container definition, and hosted it here on DockerHub. And then Caddy is the name of the image itself. I can do just what I did before, essentially. So now I'm going to run, and in this case, it's going to serve on 2015 again, right? So I need to change that port forwarding address to 2015. And now instead of Python, I'm going to use that. We see both of those containers are still running. I'm going to stop this one just to sort of clean up here. And then we're going to exec onto this container when that returns. Here we go, docker exec -it. And so here, there's actually a default index.html that they provide. I'm going to remove it and put our own there, since that is the pattern that we've been following. So here's Caddy 2015 inside container. And so we should be serving that now on 2015. Because we passed it that command line flag, we indeed can access it. Okay, so that is good. We're running our web server inside of a container. We have our website file that we had to create within that container. And so now all we need to do is sort of bundle that up and deploy it to Google Cloud Platform. There are two ways that we can do that bundling. We want to bring our files, the index.html, the Caddyfile, etc., into the container image. We can either create our own container image that builds upon the existing one, or we can, when we run the Docker command, we can give it a flag that will allow it to mount certain directories on the host system into the container itself. So why don't we start with that first one? I'll kind of show you how to do both of these, since they're both useful tools for different situations. We can define a Docker file. So this is how we tell Docker what goes into a container image. Most every Docker file is going to start with from and then the name of some other container image. So we were using a container named Abiosoft Caddy. And then we want to do two things. We want to copy from our current directory index.html, and that needs to be copied to a location in the container image. Caddy expects to serve its website from this root/serve/ and I'll just copy it directly to index.html. If we had a whole website with lots of files, HTML, CSS, many directories, we could just do something like this and copy the entire directory in that way. But since we just have this one file, I'm going to do that. And then let's also copy the Caddy file, ./Caddyfile. And that is, Caddy looks for its configuration within the /etc/Caddyfile. So that's all we need to do to define that container image. Docker ps, let's clean up this old one. Docker stop. And then, in order to turn this Docker file into an image that we can run, we will want to do the docker build command. So that'll be docker build, and I'm going to pass it this tag command. So I'll call this my Caddy container image. Oh, I forgot to pass it the directory in which Docker should look for that Docker file, which is my current directory. And so here, it's going to take this Caddy file, download that aviosoft/caddy image, and then on top of that, take these next two steps of copying in my files into those such that they'll be available. So now I could actually run this container image that I created instead of that initial one. So I'll find my command from before, this one. And so instead of 2015, now that we have that Docker or that Caddy file in our image, it should be serving on 80 instead. And then it is my Caddy container image. And so let's try. Aha, there we go. So we copied in our index.html. Let's actually change this Caddy server on port 80 inside container. In order to get that change and have it be reflected inside of that container image, we actually need to rebuild. We need to rebuild the container because otherwise it's going to use the file that it copied in at the time we built it before. So I'm going to stop that previous image, and then I'm going to do the same docker build command. There we go. Then I'm going to do the same docker run command. And so now if I reload it, I should see inside container reflected there, which we do. Awesome. So I could then take that container image as I've defined it and push it to Google Container Registry. Let's go here. Container Registry. So this is a place within Google Cloud where you can push your own container images. In this case, this is the container image that I have built and pushed for the DevOps Directive website. So we could push our container image here and then configure our virtual machine to be able to pull from here. I'm going to take a slightly different approach that I'll show you here in a second that will allow us to continue using that default DockerHub container image. So I won't have to build my own image at all, but I'll mount in to the file system within that container these files. So rather than build them into the container, I'm going to mount them in from the file system itself. Okay, so that approach is going to be slightly different. I'm going to use, there's two different flags that we could pass to the docker run command to allow us to do that. There's the mount command and the v command, the volumes command, docker mount, to create what's called a bind mount. So this allows the Docker container to access a specific folder or directory on the host file system. So here we want to do this. I'm going to mount. We're going to go back to using av/caddy. And I'm going to say pwd. So that's my present working directory. So you have to pass an absolute path into this flag or it won't work. So that'll give me the absolute path of my current directory. And I'm going to do index.html. And that is going to be mapped to that /serve/html, index.html. And again, you wouldn't have to pass the full file name. You could mount the whole directory in, but since I just have a single file, I'm making it explicit here. So that's going to handle the first one, and then the second one I need to do essentially the same thing. And I'm just going to make a new line here. So I'm going to do that. Oops, sorry. do our first volume mount. We'll do our second volume mount. So in this case, it's going to be that Caddyfile. Into the proper location. And then lastly, we need to pass it abiosoft/caddy. Oh, it's already allocated because I have that container running. Oh, I forgot to pass it the ID. There we go. So now, be able to reload here. And the interesting thing about this is now that it's mounted into my local file system, I can actually modify it here within macOS, and that change will be reflected immediately inside that container itself. Using Caddy server on port 80 inside container mounted in with -v flag. I save it, I refresh, and there I see the change was immediately reflected inside the container. So that enables us to not have to modify the container image each time. And now, when we deploy this to Google Cloud, we'll just use that base container image, and we will copy the files from our system to the virtual machine using a gcloud scp command, and then we'll be able to deploy our website that way. So I think that's all we need to do locally. We've kind of built up the necessary pieces and building blocks. So let's go back to Google Cloud Platform and deploy this website to a VM that we'll be able to actually access via the internet instead of just using localhost. I'm gonna change this because that was what was preventing us from accessing it before. So go back to Compute Engine. The reason I deleted the other one is because this instance I want to have using container optimized OS. So I'm going to change it from this Debian Linux to container optimized OS. So this is an operating system that all it can do is run containers. And so that's perfect for our use case. It has a much reduced surface area in terms of security attack surface. And so that allows us to run containers in a safe manner within Google Cloud Platform. So I've chosen container optimized OS, and I'm going to do select. In this case, I'm going to enable both of these firewall rules because I'm going to eventually, after we get it working on port 80 without HTTPS, we're going to configure HTTPS. We will create. Awesome. Okay, we have our machine. So the command that we're going to run on this VM is nearly identical to that of what we would run locally. We can either do it from within this SSH window, or we could actually pass it as a gcloud SSH command where it would execute locally, but that the gcloud command would execute locally, but pass our Docker command into the virtual machine to be run there. For now, for simplicity, let's just run it from within this SSH window once it finishes loading. Not connect. Okay. DWD. So I'm currently in home/Sid Palace. I actually noticed this when I was getting set up for this video. When I start an SSH session from the Google Cloud Platform console, I get logged in as this Sid_Palace user. When I run a command using gcloud on my local system, It is executed as user Palace, which is the user on my local system. So that was just an interesting quirk. But we need to, like I said, we need to copy our website file and our Caddy file onto the server. And so here, hello from DevOps directive, using Caddy server on port 80, inside container, on GCP. I guess we'll keep that. Mounted in with the V flag on GCP. Great. So I need to go here, and then it's going to be a gcloud scp. What is the actual command? Gcloud compute, sorry. scp / index.html. So I'm copying that file to instance1 is the instance name. I'm going to copy it to /home, what was it, /home /sid _ palace. Let's see if it lets me do that as that. Since that's not the user it's being executed as, we'll see. It might fail. I just like to pass it this project ID. You can also set a default project such that you wouldn't need to do this. Directive project. And permission denied. Okay, so it didn't like that, primarily because I'm executing as a different user. So I'm just going to copy it into my home folder of the Palace user. And then I'm going to do the same thing, but for the Caddy file. So now if I go here and I go up level, we'll see there's this 2 folders. So now I have both of those. Great. And so now I want to run my Docker command to actually spin up that web server. And we want similarly to mount in the directory that contains my website file and my Caddy file into the container image itself. So this virtual machine in this case is analogous to my MacBook. And so I need to do the same type of command. Oops. Did not mean to do that. We want to copy and then paste. Okay, so if everything worked correctly, I should now be able to go to this external IP address, and because I've configured that firewall rule for HTTP traffic, that request should make its way to the virtual machine, and then because I have passed this port forwarding into the container, that request is going to make it from the virtual machine into the container, at which point Caddy can do its job and serve us that index.html file. See if we are correct. So the default when I clicked the button there on Google was for it to automatically go to HTTPS, in which case it failed. But if I go to HTTP, we do get this not secure flag, which is annoying, and we'll fix that in a bit. But we see our website being served on port 80 from the container, making its way such that the request comes all the way into the VM instance, into the container, and we're able to get served that file. Awesome. So that gives us pretty much all we need, and the final remaining step will be to try to get HTTPS configured. In order to do that, you actually need a domain, and so I have a domain sitting around for a website that I don't really maintain anymore. And so I'm going to use that one as just the example here. So this would be where you would go in and configure your setup accordingly. So this is our external IP address. We'll copy that. We will go to my domains. I'll make it full screen there for a second. So this is a website that I don't really maintain that much anymore. And we want to go to DNS. So this is where you'll configure the settings to tell Google, in this case, as my domain registrar, where they should direct traffic, that if someone types the domain into their URL bar, where should they actually send that traffic. The way that we do that is down here with these custom resource records. So I'm going to delete the existing ones, and we're going to add two. We're going to add an A record, and an A record is going to tell us that we should point traffic going to that domain to the external IP that we got from compute engine here, 3468, etc. So that looks good. And then we want one more. That's going to be a www CNAME record, and this is going to tell Google to redirect any traffic that is at the www subdomain. So if they type in www.creationautomation.com, it will automatically get forwarded to the domain without that www in front. I can just do an @ sign here, and that will get replaced with the base domain. And so that looks good. At this point, I should be able to go to creationautomation.com, assuming it has propagated. It has not. Let's see. Oh, again, it defaulted there. Take effect in the next 48 hours. Hopefully that happens faster than 48 hours so that we can have a demo in this video. Otherwise, we'll have to come back and see if it's working later. Okay, but there is one more configuration that we need to make within our system to enable HTTPS to actually work, and that's within the Caddyfile. So this is saying serve to any domain on port 80. We want to replace this and say serve to creationautomation.com or www.creation. There we go. And we're going to say TLS palace@gmail.com. And so this TLS directive within our Caddyfile tells Caddy to automatically configure HTTPS for these domains using this email address. So it's going to send off a request to Let's Encrypt, the certificate authority, and they're going to check whether I do indeed own this domain, which I do. And so hopefully that will succeed. And then we will be able to it will issue a certificate such that I can serve this website over HTTPS, and we'll be able to connect to it and get that nice lock symbol in our URL bar. So let's we need to do two things. We need to copy this file back onto the virtual machine. So we were here. Okay, that's there. Let's make sure it looks like we want it to. Creationautomation.com looks good. And then we need to rerun our Docker command, but we also need to port forward port 443, remember, because that's where the secure web traffic is going to come over. 443 -v. And so if I run this, didn't like --p. Oh, single dash, not double dash. 80 is already allocated. Okay, again, I keep forgetting to clean up my old resources. let's see. Still nothing here. Let's, rather than run it as a daemon, let's actually run it so that we can see the output directly. Yes. If I could do that correctly. There we go. We're going to get rid of this -d, and that's going to allow the logs to actually come out. Oh, it was because it was asking whether or not I would like to, whether I'd like to accept the terms of Let's Encrypt, and without that, it would fail. Okay. And so validation succeeded. That's good. And actually, I could get around this particular issue. Oh, hey, look at that. So it requested certificates for my domains, and now it was successfully able to serve to those two, both my www subdomain and my root subdomain. And so now I can load this web page, and I get a connection is secure symbol. And so that is great. But what I was saying before is that I could have avoided this dialog by using the acme_agree flag. So I could set this environment variable in my Docker run command, and then the container image as defined here would use that to accept that license agreement on my behalf. And so the way that I would have actually done that would be to use the -e flag. So in this Docker run command, I could have somewhere like here done -e acme agree equals true, and then I believe that would be it. And so in this case, here's another interesting thing. Remember before when we killed the container image locally, and then I had to recreate the index.html within it? The same thing is happening here, where I destroyed my server container on the VM. And so the next time that I relaunched it, it had to check and request those certificates. I could, and I would, actually mount in the location in the container where it's expecting to save those, save the certificate files. I believe it's in the .caddy hidden folder directory. And so I would mount those in such that even when I bring the server up and down, that certificate would persist, and I wouldn't get rate limited by the certificate authority. But overall, that is exactly what we wanted. I have a project on GitHub that actually automates all of this. And so as you saw in the previous video, I was able to do this entire process in an automated fashion in less than 5 minutes. But that is GitHub, you go GCP deploy. And so this makefile has a variety of commands that actually script the entire thing. So it goes through, it creates a site using a site generator, creates the GCP project, configures the VM, and then builds and deploys the container image, just like we did manually, but actually does that automatically here within the script. So hopefully that was useful and educational, and sort of walking through from the most basic single web page, single line web server in Python, building up into deploying that onto a Google Compute Engine virtual machine, taking a step back and trying to understand how to bundle up the server and the site into a Docker container. And then once we had that configured and tested locally, we actually deployed that container image to Google Cloud Platform. And so this is the exact setup that I'm using right now. I did put Cloudflare in front of it, but other than that, this is the identical setup to what I'm using for the DevOps Directive website. So I'm excited to sort of do some benchmarking and start to understand what this tiny little server with 0.6 virtual CPU and or not even, I think it's like 0.2, but it can burst up to higher virtual CPU and 600 megabytes of RAM to see what kind of traffic and load and performance we can get out of a tiny little virtual machine like this running on Google Cloud. So with that, I think I'll close out the video. This is Sid with DevOps Directive. Take care. See you in the next one.